Hello and welcome back. What we're going to be doing today is we're going to be talking about the area of regular polygons. And we're always going to come back to this formula, that the area is equal to 1/2 of the perimeter times the apothem. 1/2 of the perimeter times the apothem. In other words, we need to find, in order to find the area of a regular polygon, we need to find the side length, because then we'll be able to find the perimeter, and then the apothem, the height of that little isosceles triangle that's in every regular polygon. And there are three different ways that we can do this problem. Three different givens that we can be given. We can be given the side length, we can be given the apothem, or we could be given the radius. And we're going to do each one of those in turn. So let's start with the first one. And for the first one, let's say we have a pentagon. We'll have a pentagon with side length, let's go with 8. Pentagon with side length 8. So already we know that the perimeter will be 5 times 8, which is 40. Now we just need to find the apothem. And I've got my handy dandy calculator here. Hopefully it's not too glary, but here we go. So let's just draw in our pentagon, and I'm going to try to do my best to make a regular pentagon. That's not bad. It's not great either, but it's not bad. It's a regular pentagon. That means all the sides are the same length. And what we're going to do is we're going to draw in one triangle here. It's going to have a side length of 8. And then we're going to need to find the apothem. And the apothem is this vertical line, that perpendicular line. There's my apothem. And so in an isosceles triangle, we know that that bisects the base. So we know that. And so now we're going to be able to draw. I'm just going to want to draw in just the right triangle. Now, before we do that, we need to find the central angle. And the central angle up here is, there's going to be 5 central angles that are all congruent. 5 central angles that are all congruent. And they add up to 360. So that means each one of them is going to be 360 divided by 5, which is going to be 360 divided by 5, which is 72. 72 degrees. But I'm going to focus my attention on just the half triangle. So we're going to look at this right triangle here, and it's made up of a radius, it's made up of the apothem, and it's made up of the half side, 4, and the angle at the top, it's not 72. That would be a full central angle. It's a half of a central angle, which is 36 degrees. So I need to find the apothem, which means I'm going to need to use some trigonometry. And I'm given the angle, and I'm given an opposite side, and I want to find the adjacent side. So to me, that means we're going to need to use tangent. So tangent of 36 degrees equals opposite over adjacent, which is our apothem. And I've got the a in the denominator there. So what I want to do is I'm going to multiply both sides by a and divide by the tangent of 36. So we're going to get a is going to be exactly 4 times the tangent of 4 over the tangent of 36. Sorry, I changed pen colors here. That's okay. And now is the time when I'm going to use my calculator, and I'm going to plug this in. Notice I'm in degree mode. Very important here. Don't want to be in radian mode. 4 divided by tangent of 36. And that's going to give me that a is approximately equal to 5.51-ish. And so now I've got a, I've got my perimeter P, and now I can just plug it into the formula. So the area of this pentagon will be equal to 1/2 of the perimeter, which is 40, times the apothem, which is 5.51. And I can plug that in my calculator. Well, I'm going to cancel those out and just make those 20. So I'm going to multiply what's in my calculator by 20 so that I don't have to deal with the rounding errors. And what I have is I have the area is approximately, this should have been approximately as well, the area is approximately 110.1 units squared. So that was the area of the pentagon that's got a side length of 8. Now let's go on to the second type of problem we could see. So here we were given a side length. What happens if we're given the apothem? That's part 2. Part 2. What if we're given the apothem? So again, we're going to be given area is 1/2 perimeter times apothem. And this time, let's do a, I don't know, how about an octagon? Octagon. I look at it and I feel like there should be an A in there, but I feel it's all right. Octagon with apothem equal to, let's say 3. So apothem is equal to 3. So let's draw in our octagon here and see what we have to find. Well, we have the A already. We just need to find the perimeter. So I bet you can already kind of see where we're going. But I want to show you how we're going to get there. So I'm going to start by drawing a circle. But it helps me to draw an octagon, actually, because what I can do is I can draw 2 endpoints of a diameter. I'm going to draw sort of north, south, east, and west, and then I'm going to draw northeast, southeast, southwest, northwest, and these are all evenly spaced around my circle, and that helps me to draw a very lovely, regular octagon. Very proud of this. This is much better than my regular pentagon from earlier. Here's my regular octagon, and we're going to have the center of the circle is here. We're going to have the radius goes like this and like this, and here's my apothem. And so that's the information I've been given, and I need to find that side length. So I'm going to do the same thing that I did before, which is I'm going to examine not the full isosceles triangle, but just the right triangle right there. And that's going to be something that looks like this. Again, here's my apothem. It's got length 3. And here is this part here, which I'm going to call x, because it's half the side length. I don't want to confuse that with my side length, so I'm going to call it s. And I just need to know an angle in here. And again, I'm going to rely on the fact that we've got a bunch of these central angles here, and each one of them, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to divide that full circle up into 8 pieces. 360 divided by 8 is 45 degrees. So that would be the full central angle, but I don't need the full central angle. I'm going to use half the central angle here. That's 22.5. 22.5. Should have made my drawing a little bit easier by making it bigger. But alas, here we go. Again, I've got an angle. I want to find the opposite. I have the adjacent. So again, opposite and adjacent, that tells me I'm going to use tangent. So tangent of 22.5 is going to equal the opposite over the apothem. And this time it's a lot easier to do. I can just multiply both sides by 3. 3 times the tangent of 22.5 equals x. That's exactly what x is. And then we can figure out what x is approximately equal to by using our calculator. X is approximately equal to 3 times the tangent of 22.5. And that's going to give me 1.24. But remember, x is 1.24. And what that means is my side length here, s, my side length, is twice that amount. So we multiply that by 2. That's 2.485 and some change. And I'm not interested in the side length. I need to go all the way to the perimeter. So I'm going to multiply that by 8 because this is an octagon. So I'm going to multiply by 8. And that's going to give me approximately 19.88. Notice that I never rounded. I just kept using the answer for my calculator. That's a good way of not introducing rounding errors into your calculations. So there's my perimeter. It's approximately 19.88. And now I'm going to feed it into my formula for the area. The area will be approximately 1/2 of 19.88 times 3. And again, I'm going to keep going with this answer for my calculator, not what I've written down there. So I'm going to multiply this by 3 and divide by 2. And that's going to give me an answer of approximately 29.8 units squared. Again, I don't want to add any rounding errors in. So I want to keep my calculator with as much precision as possible. So I'm not going to plug in the 19.88. By the way, if I did that, let's see, 19.88 times 3 divided by 2, that would give me an answer of 29.82, which would round to the same, but it doesn't always work out that way. Especially maybe if I did like 19.9, maybe I rounded that to 19.9 times 3 divided by 2. So then I would get 29.85. That would round to 29.9. And I've introduced some rounding error in there. So I don't want to do that. Okay, the last and most complicated thing that we could do is to find the area if I was given just a radius. So let's start with a decagon here. Decagon with a radius of, let's say, 7. I don't know. It's a lovely number. Have I used that before? I don't think so. Decagon, radius is 7. Again, we are thinking about perimeter equals 1/2 PA. This time I have neither the the area equals 1/2 PA. I have neither the apothem nor the side length to find the perimeter. So I'm going to be doing a lot of work here. I have to find both pieces. So here's my circle. I'm going to divide it in half. And this time it's a little bit harder. I got to divide this into 10 equal pieces. So that's a little harder. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 pieces there. And I'm going to draw in again 4 equally spaced pieces around here. That didn't end up so equally spaced, but it's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my decagon. It's lovely. It's more or less regular. And this time we're given the radius is 7. And we need to find both the apothem and the side length. So there's the apothem. And let's redraw this bigger. I learned my mistake from last time. I'm going to draw this really big. And of course, I always recycle or reuse all of my paper for other purposes, so it's not going to waste. There we go. But I like to make my drawings nice and big so that I can label things the way I want. Here's X, here's S, it's the full side, and here is A. And this time, I'm going to need to find both X and A and S, of course, and let's see how this goes. So, need to find this angle here. This is a decagon, so that means that my central angles here are all going to be 1/10 of the circle, and 1/10 of 360 is 36 degrees. So that means my half central angle up here is 18 degrees. And now we're going to start the process of finding X and A. So let's do apothem first. Apothem. Notice I'm titling my work as I go, so I know what I'm actually doing in this little piece. So to find the The apothem is adjacent, and I have the hypotenuse, so that means cosine. So I'm going to do the cosine. Cosine of 18 degrees is equal to the apothem over 7. And that means I'm going to multiply both sides by 7. And I'm just going to write it like that. That A is equal to 7, the radius, times the cosine of 18. I'm going to keep that just the way it is. I could find that if I wanted to, but I'm just going to hold on to it just like that. Okay, now let's find x. So we're going to find x. And x is the opposite side from 18, and I'm going to again use the hypotenuse. By the way, I could find a and do the Pythagorean theorem to find x, but again, that would introduce a little bit of rounding error, so I'm going to just keep going the way I am. 18 is the opposite, and I have the hypotenuse exactly, so this time I'm going to use sine of 18 is the opposite, which is x, over the radius, which is 7, and that means that x is equal to 7 times the sine, this time, of 18. And then that actually tells me, put a box around that, that actually tells me what s is, the full side length. That the side length is equal to twice that amount. So I'm just going to multiply this all by 2, and that's going to give me 14 instead of 7. So 14 times the sine of 18 degrees. Okay, let's put a box around that because I'm kind of at the done part there. And wait, hold on. If I know s, I really know the perimeter because there's 10 sides to this. So the perimeter will equal 10 side lengths. So that's going to equal 10 times this, which is going to be 140 times the sine of 18. So that means my area, so now I have perimeter. I'm boxing a lot of stuff here as I went along. So the perimeter is going to be equal to 140 sine 18. So the area of my decagon is 1/2 the perimeter, 140 times the sine of 18, times the apothem, which was 7 times the cosine of 18. Okay, so this was my perimeter, of course, and this was A. And now I can go ahead and do a little bit of canceling here. The 1/2 will cancel out with the 140, making this 70. And then I can plug all of this into my calculator at once. And again, I like to do this because the fewer times that I write down the answer, then the less rounding error I'm going to have. So the area will be approximately equal to 70 times the sine of 18, close parentheses, times 7 times cosine of 18, close those parentheses again, enter. And that gives me an area of approximately 144 units squared. 144 units squared. And I've done a lot of calculations there, and I should think if there's I should try to figure out if there's a way for me to know if that answer makes sense. And it goes back to looking at the circle that this decagon is in. The circle has a radius of 7. So the circle's area, we know that the circle's area is equal to pi r squared. In this case, that's going to be pi times 7 squared. That's going to be 49 pi exactly. And rounded, let's see, 49 times pi gives me 153.9 units squared. And that makes me feel like my answer of the decagon's area being 144 is really a good answer because It couldn't be more than the circle because the decagon's got to be inside. And the decagon with that many sides is going to be really close to the area of the circle. There's not that much gap left over. So 144 is pretty close to 153 without going over. So to me, that means we're all good. So these are all the different ways you could encounter the givens for a regular polygon area. Good luck with your own problem solving, and I'll see you next time.